In this video, you're going to learn how to solve systems of linear equations. When you solve the systems of linear equations, it's important that you recognize that the solution to a system of linear equations is 1 point. So when you do write an answer to that, there should be an x comma y, so one ordered pair. What I also want to point out is, as you get into algebra next year, you're going to be learning many different ways to solve systems of linear equations, as well as systems of other types of equations, like quadratic equations. But for right now, I just want you to understand that when both equations are set to equal the same letter, like both are in slope-intercept form, so they both equal y, or are for some random reason they both equal x, you can set those two equations equal because of the transitive property. And if one equation is in slope-intercept form and the other equation is in standard form, while you can take the standard form equation and put it into slope-intercept form, you can also take the slope-intercept form equation and substitute it into the standard form equation, which is what this video shows you. So you're going to get more in depth with that next year, and you're going to learn also about a method called elimination, but we're not doing that. We're simply doing when the equations are equal to the same variable, and also a little bit of substitution. So in this video, we're going to look at systems of linear equations. And basically, a system is more than one of something. So in this case, it's more than one linear equation that's graphed on the same coordinate plane. And the solution to a system of linear equations is the point, points, or no points where the lines cross. So in most cases, you're going to have lines that intersect at a point. But if you happen to draw the same line, which I know sounds really weird, like why would you draw the same line twice? But if you did, that would be all solutions. Any point on one line would be the same as any point on the other line, so all points would be a solution. And then if you had parallel lines, those lines would never ever meet, so there would be no solution. So this is a flashback to when we were solving with equations with variables on both sides, and we would end up with all solutions or no solutions. All solutions would be the same line, and no solutions would be parallel lines. Or there's just one point, which is really what the focus of this slide is. So I have my two linear equations. They happen to both be in slope-intercept form, which is great because that makes my job easier. Remembering my goal is to find the x comma y where the points meet. I can say that what I really want to do is know when the y values and or the x values are exactly the same. So if I have y equals 3x plus 1 and y equals 2x minus 4, then the transitive property says if a equals b and b equals c, then a equals c. I can set 3x plus 1 equal to 2x minus 4 because they both equal y, and I want to know when they both equal the same y. So from here it just becomes a solving equations. So you're going to go ahead and bring one of the x's to the other side, and then isolate the x. So in this case, when x is -5, the two equations will meet. So now my goal is to find the y value, because I don't really just care about the x value, I care about the y value as well. So I don't care which equation I plug it into, it should result in the same answer. I get that y is going to equal 14, -14. And so my point where they both meet is -5, -14. And that would be the answer. That would be the solution where they cross. I could always check by plugging that point into the second equation and finding out that in fact it is correct. So now I have an equation that's in slope-intercept form and an equation that's in standard form. So I can solve this one of two ways. The first way is I can convert both of them into slope-intercept form. The good news in this case is that only one needs to be converted into slope-intercept form. So I'm going to go ahead and convert it into slope-intercept form by subtracting the 2x from both sides and then dividing both sides by 2. If how I just did that is confusing to you, then we need to talk, or you need to rewatch the standard form to slope-intercept form video. So I know that 2x plus 2y equals 4 is the same as y equals negative x plus 2. So now I have y equals negative x plus 2 and y equals 4x minus 3 as my two equations. Now they're both in slope-intercept form. So because they both equal y, and my goal is to find the one value of y where they both are equal, I'm going to set them equal in order to find out what that would be. I'm going to add x to both sides, and I'm going to get 5x minus 3 equals 2. I'm going to add 3 to both sides, and I'm going to get 5x equals 5. Divide by 5, and in this case, I get my x value as 1. That's wonderful news. Now I need to substitute 1 in for x in either one of the equations, and to be able to find out my y value, and it happens that my y value is also 1. Well, if I plug 1 and 1 into the standard form equation, I do get 2 plus 2 is 4, so I therefore know that 1 comma 1 would be the correct solution. So there's also a way where you can keep the equations in the forms that they are in. And this may be confusing to some of us, so I encourage you to go with the way that works for you. So in this case, I know that 2x plus 2y equals 4 and y equals 4x minus 3. So I'm going to substitute the entire 4x minus 3 in for y in the second equation. So that means that instead of y, I'm going to have 4x minus 3. So I just took one of the equations that was in terms of y and plugged in that entire expression in for y. Remember, when I do that, I need my parentheses, because anytime I have binomials or polynomials, terms, more than one term, I need to put them in parentheses. So now it becomes a solving equations deal where I distribute, I combine like terms, I solve my equation, and I again get x equals 1, which is great because I'm hoping no matter which way I solve the equations, I'm going to get the right answer. To find my y value, again, I choose one of the equations to substitute it in for. I will choose again the same one I did before, and I get y is 1. So either way that I do it, I get 1 comma 1 as a solution. So in this case, neither of the equations happens to be in slope-intercept form. Neither of the equations are actually in standard form. They're both in some funky form, but luckily for us, they both equal the same variable, and in this case, it's x. So there's no need to convert these equations to slope-intercept form unless you choose to. But for me, if they both equal the same variable, then it makes my life really easy, because now, instead of solving for my x like I did when I set the equations equal in terms of x, now I'm going to set them equal in terms of y. Well, that's fine. If they both equal x and I want to know the point that also has an x value where they're equal, I'm going to set them equal to each other. And then now, instead of solving for x like I've been doing, I'm solving for y. But that shouldn't change anything, because my point's still going to have an x, and I'm still going to be able to find that x by substituting y in. So when I solve for y in this case, I get that y is 7. So now I'm going to plug 7 back in for y in one of my equations. And when I do that, I get that x is 14 plus 6, so x is 20. So my point would be 20 comma 7, because it's x comma y. And I could always plug in 20 and 7 into this equation and make sure that I also get that same number, and in fact I do. So I know that at 20 comma 7, my linear equations cross, my lines cross.